How does text preprocessing reduce data sparsity in NLP? Imagine trying to understand a conversation where everyone speaks in different accents, uses slang, or mumbles. It's hard for a machine learning model to make sense of such cluttered data. That's where text preprocessing comes in. It acts like a translator, cleaning up the mess so models can learn better. When working with natural language processing, or NLP, the goal is to turn raw text into a form that computers can analyze efficiently. But raw text often has many unique words that appear only once or twice. This is called data sparsity. It makes it tough for models to find patterns because there's not enough repetition of the same words. Preprocessing helps fix this by making the text more uniform and easier to work with. One simple step is lowercasing all words. Think of it like turning all words into lowercase letters so that apple, apple, and apple are seen as the same word. This boosts the count of each word, reducing the number of rare variants. Cleaning the text is another key step. Removing punctuation, special symbols, URL, and extra spaces gets rid of noise that creates many meaningless tokens. When the text is cleaner, models focus on important words instead of distractions. Tokenization is like breaking a sentence into smaller pieces, usually words or parts of words. Without it, models might treat entire sentences as one big token, which is very sparse. Breaking text into tokens makes it easier for models to understand and learn from the data. Removing stopwords is also helpful. Words like the, and, or is appear very often but don't add much meaning. Taking them out reduces the number of tokens the model needs to handle, making the data less sparse. Stemming and lemmatization are techniques that reduce different forms of a word to a common root. For example, running, ran, and runs all become run. This reduces the total number of unique words and increases how often each appears. Normalization is about standardizing formats, like fixing date or number representations, so they look the same across the dataset. When all these steps are combined, the size of the vocabulary shrinks. The words that remains are more common and appear more frequently. This creates a denser dataset, which helps deep learning models like ChatGPT understand language better. It also improves the performance of specialized AI tools like DALL-E or Midjourney that relying on clear text prompts. Productivity plugins that analyze or generate text also benefit because they work with cleaner, more consistent input. In short, text preprocessing reduces data sparsity by cleaning, standardizing, and simplifying text. This makes it easier for models to learn meaningful patterns and produce better results. It's like tidying up a cluttered room so you can find what you need faster. When the data is less sparse, models can understand language more accurately and generate more relevant responses.